So I'm sorry for all the beeping and clicking and moaning and groaning in my maximum minimum with intervals note, lesson video, co-video, as I like to call them. Um, I was getting massive error messages and I didn't want my 15 minutes of talking to go to waste, especially since I was getting a hand cramp. So I'm moving on to number and money questions. Now, there are a lot of types of questions, so I'm going to break them up into different kinds, and every time I give you a list of questions in this unit, except for the with interval questions, it will come from a maximum minimum word problem booklet that is on the Google site. And I will have given that to you in class if you were in the class. So here is a list of steps that are for all optimization problems. So step one is to create an equation based on the problem. This is easier said than done. This is the critical step in the process, and I also can't spell critical. This tells me if you know what's going on, if you've completed your homework, and practiced each type as they are delivered to you. So this is the kicker. This is where people screw up, because if they screw this up, they don't answer the question properly. That is not to say you get 0. You get part marks for working on something that is incorrect that you believe is correct, and then following through with your situation. So that's called perseverance. So back to the steps. This could be one equation, or it could be two equations where you sub one into the other. And your choice is, and it depends on the type of question, you include a let statement, or you include a label diagram, or if you prefer, you could do both. Once you get an equation, you take the derivative, and because it's a maximum minimum problem, regardless of whether it's maximum or minimum, you let the derivative equal 0, because that will give you a slope of the tangent that is 0, horizontal. You solve for the x's, or whatever letter is in the question. Then you reread the problem to make sure you're answering the question, and you do this with words, because these are going to be word problems, and you're answering a situation rather than with the last questions with points. And so you do this with words, and you do it with a therefore statement. So if you want to, you can pause and write this stuff down, but I'm carrying on with some number questions. So I'm going to put this back to regular screen. And here is question number 1 for number questions. So there's 2 number problems, and there's 2 money problems. Number problems rarely show up in air quotes real life. They are to help you get used to how you do these questions. And then money problems are revenue problems, meaning that you will use them in real life if you're doing any sort of business activity, because you are going to want to minimize or maximize money depending on your situation. So I am going to color code this, as I like to do. I am going to leave myself some room as well for the let statement, which I usually come back and take care of. So I'm going to let, and then I'm going to tackle this stuff. So in red, I'm going to translate this. So it says the sum of 2 numbers is 28. So that actually means sum plus is equals 2 numbers unknown. So x plus y is equal to 28. Then I'm moving on to the second question. So this is where I'm going to dig out a totally different color. It says find the numbers. So I don't know what the numbers are. If the sum of their squares, so sum squares is a minimum. So over here, I'm going to write minimum equals x and y sum squares. Now, before I forget, let x and y represent the numbers. Nothing fancy. Can't draw a picture for this. So the problem with this, which is what you want to take the derivative of because it's the minimum or maximum statement, is we don't do 2 letters. So what we need to do is we need to come back over to the red side and rearrange. So I'm going to rearrange to get y all by itself. That means pulling x across the equal sign and subtracting. And then I'm going to come back to the blue side. And I'm going to put in 28 minus x where there's a y. I need brackets, and because it's y squared, I'm going to write it down twice so I can FOIL. Because the alternative would be the power of a function rule, and I want to avoid that at all costs. Especially since I can FOIL. Oh, can I FOIL? 28 times 28. I need this baby. 28 squared. Didn't think it was that big. 784. Don't need any brackets because it's just a plus sign sitting here. Subtract 28x. Subtract 28x plus x squared. And I'm going to collect like terms, and it doesn't matter your order. This isn't a factoring question yet. So x squared and x squared is 2x squared minus 56x, negative 28 and negative 28x, plus 784. So I am done step 1. I now have to take the derivative and let the derivative equal 0. So this is going to be minimum or maximum prime. So 4x minus 56. And then I have to let that equal 0, and I have to solve for x. So thankfully no factoring, but I do have to get the x by itself. So 114. So I need to reread the question. Create the equation, take the derivative, let the derivative equal 0. I have solved. Now I need to reread the problem to make sure I'm answering the question. Find the numbers. So I need to find the x and the y. So I know what my x is. It's 14. So I can take 14 and put it back up into y to get the other one. And it just happens that both numbers are exactly the same. And then I need the therefore statement, which should not read x equals 14, y equals 14. You should make it a therefore statement, meaning with words. So therefore, the numbers are both 14. We'll do it. So I'm done that. And I'm on to the next number question, which is probably going to use a little bit of different language so that I give you some different kinds of examples. But I'm still going to set it up the same, as in I'm still going to leave room for a let statement. I'm going to make a statement here. I assume I'm going to need 2 of them, so I'll color code. So this question says 2 numbers. So let x, y represent the numbers. I can guess that pretty readily. It says 2 numbers have a difference of 8. So that means x minus y is equal to 8. Find the numbers if their product, so that's times, is a minimum. So I've got minimum equals, so no sum of squares, no squares at all, just that. Now, my recommendation, just because this is what you are used to, because of all the work with functions and graphing in calculus, is that over here on this side of the page, when you're trying to get a letter by itself to replace one of the 2 over here, you try to get the y by itself, which means I also want it to be positive. So I'm going to pull it over to the right, and I'm going to pull the 8 over to the left. And then I can sub it in. So that this question, or sorry, this work is all done with x's, and that's pretty regular looking. Now, you can take the quotient rule, product rule if you want here, but because it's fairly easy to multiply this out, it might be to your advantage to multiply it out and then take the derivative, because that avoids the product rule. It also means that I've got something fairly simple to make equal 0, and yes, you must show that 0 because everything else follows from there. And now take the 8 over, leave the 2x behind, divide by 2, divide by 2, x will equal 4. reread the question. Two numbers have a difference of 8. Find the numbers if their product is a minimum. So if I think that x is 4, I should be able to find y by plugging 4 back in for the x. And if you think about it, 4 and negative 4 do have a difference of 8. There's 8 numbers between them. And therefore, the numbers are negative 4 and positive 4. Or you could say plus minus 4. All right, so that's enough of questions for no reason other than practicing the math. Let's get into some money problems. More specifically, revenue problems. And you would have done these kinds of questions actually, you would have done number problems, the kind we just finished, and you would have done revenue problems in grade 10. And if you had me for grade 10, you definitely did them. You would have done them in quadratics, because this question was quadratic, so you would have found the vertex either by using the little formula or completing the square. This one is also quadratic, little formula, or completing the square. What calculus lets you do is it lets you get outside of quadratics and do this stuff with anything, because all you're doing is looking for maximums and minimums. So we're practicing some stuff you have some familiarity with. Oh, I said that wrong again. That you've done before. The other questions, not so much. So this, I'm going to start with a let statement, but I don't know what I'm going to let it be because I haven't even read this yet. And this is my favorite kind of question. So it says a theater seats 2,000 people at $10 per ticket. If the ticket price increases, the number of tickets sold will decrease by 100 for each dollar that these people decide to increase their price. What ticket price would result in maximum revenue? So we have to discuss what revenue is. And revenue is you taking, in this case, the amount of people and multiplying it by how much the tickets cost. So the tickets times the cost. So for us, we are trying to maximize revenue. So we can take 2,000 people at $10 a ticket. And I highly recommend you put in the dollar sign so you don't have to determine which one is your money bracket. Now you'll notice that I left a giant space here because there's more to the question. Because it says if the ticket price increases, the number of tickets sold will decrease. Well, that makes sense. But the number of tickets sold will decrease by 100 people or 100 tickets every time we increase by $1. But maybe we want to increase by $2, which means we're going to lose 200 people. Or $3, which means we're going to lose 300 people. All we know is that its multiples of 1 will cause multiples of 100 people less. So we need an x in there, and then I can complete my let statement. So let x represent, I'm going to talk about money. So I'm going to say let x represent the number of increases in money. So you can do the product rule here, or if you prefer, you can FOIL and then take the derivative after. So I'm going to FOIL because foiling is pretty easy for me. So 2,000 times 10, 2,000 times 1x, 100x times 10, and 100x times 1x. And then I'm going to collect like terms, and notice how I am not taking the derivative yet. So collecting like terms. Now I get to take the derivative. So by doing this more familiar math, you get to avoid the product rule here. Because now I can take the derivative of this way easier. So negative 200x plus 1,000. And yes, I need to set that equal to 0 and you will lose a half mark if you don't show that 0, because if you start dragging things across the equal sign without having a 0 there, your math is actually non-logical. So I'm solving for x now, and I end up with x is equal to, 5. Well, that's great. I've forgotten what the question asks. So the question says, what ticket price would result in maximum revenue? So here's where putting that $ in helps, because we're going to have to take that x equals 5 and put it in here, because this is my ticket price bracket. If it said how many tickets will be sold to maximize the revenue, you would put it into your people bracket. And then the other possible question would be, how much did they make, in which case you'd put it back into both brackets and times them. The easiest question would be, how many times did they raise the price? And then you would say 5 times. So I'm just going to scribble down this. So ticket price is equal to 10 plus 1x. So I don't have to remember that to the bottom. And then I can take that 5 and I can put it in there, which is pretty simple math, and come out with an amount, and then I can answer the question. Therefore, the price should be $15. All right, I think the last question bumps this up a notch. Okay, so before I even start, I see a $, so I'm going to do this. Oh, before I mention it, before I forget to mention it, number problems often require 2 equations where you use one to sub into the other. So there was an example, and here was another example. Let me do that and that. But money problems often just ask you to think about the logic of the questions. And hopefully you can see why somebody would actually need this. So there are studies done, and then what happens is the studies result in a maximum profit or a minimum cost or whatever it is they're after. So I'm going to assume that this is a let x represent question rather than let x and y represent. And we are looking for profit this time. So a shop can sell 30 radios per week at $20. So 30 radios at $20. There's my $. If the price is increased, for each dollar increase, there will be a loss of 1 sale per week, but we don't know that it's 1-to-1. Maybe it's 2-to-2. So we can stick an x back there, and I can say let x represent the number of dollar increases. Now, I haven't finished reading yet. So if the price is increased, for each dollar increase, there will be a loss of 1 sale per week. The cost price of each radio is $10. So that means they're not actually going to make this much money for every radio they sell. They're going to have to minus off how much it costs them, which is $10 for every radio. And this is the number of radios, because it doesn't have the $. Yes, you could have gone in here and minus 10, but I do it this way in case there's anything funky going on in the question. So, do you want to do the product rule and then this, or do you want to FOIL? The answer is entirely up to you. I'm going to FOIL. 600 plus 30x minus 20x minus 1x squared minus 300 plus 10x, collect like terms. And it doesn't matter if you have maximum over here or minimum or profit or you can't have x in this question, and you can't have x's and y's in number questions. You just have to pick your letters, and I pick them semi-logically. So negative x squared, this is 10x plus the other 10x is plus 20x, and then 600 minus 300 is 300. And I still haven't taken the derivative, which is kind of the point of this stuff. So negative 2x plus 20. Set it equal to 0. And get x by itself. And then reread the question. So these people are pretty greedy. They're actually going to increase by $1 10 times. But it says what is the price that will give the maximum profit? So we don't care about cost, except we had to factor that in. The price bracket is right here, because I was smart and put the $sign in. So price is equal to 20 plus 1x, so 20 plus x. And x is 10. So therefore, what are these about? Radios. Radios. Therefore, 1 radio should cost $30. Now, before I leave you, because that is the end, before I leave you, I do want to tell you that every single one of these was quadratic. So this was quadratic because our last statement before taking the derivative was an x squared. And because it was a positive x squared, our quadratic was like this, which means we did have a minimum. So the questions are set up. Here's another one. This question was a minimum. It was a positive x squared. When we got to the money questions, where I hope that it's logical that you want to maximize your money, when we get to a point where you start taking the derivative, it was a negative x squared, so you're shaped like this, and you're finding the vertex, which is a maximum. And the same thing here. Here's your last line before taking the derivative. It's a negative x squared. So this is really easy to determine whether you're kind of doing things right if it's quadratic, but if it's worse than quadratic, which it becomes in calculus, even this year, then you can't tell as easily. So you're going to have to make some decisions. So that is the end of number and money questions. I will be back with some other word problems, all of them referring to the booklet on the Google site. This one worked out. Yay!